Okay, going to do another proof here. This one deals with perpendicular segments and isosceles triangles. So just looking at the given, let's mark it. Given AF, so is perpendicular to FR, and MR is perpendicular to FR. I also have that FRD is isosceles with vertex D. So I have this. And I'm trying to prove that triangle FAR, so I'm going to use a highlighter just for a minute, FAR, so you can see what I'm looking at, is congruent to triangle RMF, and so in looking at all that information, I have to process it all, and it looks to me like I'm going to use overlapping triangles. So when I pull that out, I have this triangle and this triangle, and I'm going to try to show you how I'm going to put the letters to this. So the left triangle would be FRM, and I have that right angle here, and the right triangle is RFA, and I have that right angle here. I have the same segment, and the question is, what is going on here? Why do I have that? So if you think about it, I need one more pair of congruencies in these yellow and pink triangle below, and the key is coming from the isosceles triangle. So far, just kind of doing a little scratch work, I know that I'm going to use the fact that angle AFR is congruent to angle MRF, because I know right angles are congruent. And I'm going to also use that FR is congruent to itself. So I have two things, but I need a third. And it turns out the third thing is going to come from the isosceles triangle. So just a little bit more use of a highlighter to draw attention to what I'm talking about. We're told this is isosceles here. And what that gives me is congruent angles here. And that, in this picture, transfers to these here. So there's a lot of thinking in this problem. So that's my third piece. Angle FRA is congruent to angle RFM. Once I have those congruent, I can say that the triangles are congruent. Triangle FRA is congruent to triangle RFM. And it looks to me like that would be by angle side angle, which would then give me angle FAR congruent to angle RMF by corresponding parts. So it's not a long proof, but it took a little more thinking. So this is how it's going to go. To speed the process up, I'm going to use a little bit of the camera tool here. Whoops. So I'm going to put in some key things here. I know I'm given this. So I'm going to slide that up right in there. Got a little extra line in there. That's okay. And I'm given this. And I'm going to slide it in there. And the results will do some writing about. So let's just move this out of the way and start writing. So this is given. And this is given. And because I have perpendicular lines, I know that angle AFR and also angle MRF are right angles. And the reason is perpendicular lines intersect to form right angles. And so therefore, I know what we talked about here, that the right angles are congruent. So let's put that in there. And the reason for that is that right angles are congruent. Okay. And then all of these sequences, this whole like first part, that needs to stay together. It didn't have to go first. So in other words, I could have put the same segment first, if that's what came to mind first. Like FR is congruent to FR. So that's the same segment property. And now I have two of the three pieces of my angle side angle both. So the third piece is to use the isosceles triangle statement. So I'm going to go back to kind of shortcutting this. Just take a little picture over here of this. And it's doing a funny thing with the, let's bring that over here. I'll just try one more time. Let's go over here. Let's try that one more time. Yeah, camera tool's not working great. I'll just write it in. I think there's too much going on here. So triangle FRD is isosceles with vertex D. That just means D is the symmetry point. So that's given. So the result is that we know that FD is congruent to RD. And the reason is an isosceles triangle has has at least two congruent sides. And because we have two congruent sides, we can say that angle FRA is congruent to angle RFM. So that's this angle here, up here, because there was something called the Isosceles Triangle Theorem, and what it says is if two sides of the triangle are congruent, the angles opposite are congruent. So if two sides in a triangle are congruent, then the angles opposite the two sides are congruent. So the angles opposite the two sides are congruent. So here's something that's important to notice. I need to have this statement, and this statement to use my angle side angle. There's also another congruent statement here, but that congruent statement just led me to the one I'm using. So you have to have at least three things congruent to come up with congruent triangles. I just happen to have four because I needed this one here to get to the one here. So now I'm going to take this statement on the left here and say the triangles are congruent. So now I can say triangle FRA is congruent to triangle RFM by angle side angle. So therefore, I can say angle FAR is congruent to triangle angle RMF by the corresponding parts of congruent triangles being congruent. So I've done my job. Finish that proof. I'll stop that after I do one more. So we're going to do this kite proof now. So I already kind of marked this up because we were talking about it in class, but if you want to see what it looked like originally, it would be just a picture here. And then the given is that you have a kite. K-I-T-E is a kite. And so we know kites have two pairs of congruent adjacent sides that are distinct. So in other words, K-E and K-I are congruent. But we also know, because it's a kite, that these would be congruent. And then we're going to use the same segment property. And we want to prove in the end that KT, so we want to prove that this segment KT bisects EKI into two congruent parts and ETI into two congruent parts. So we're trying to show like the little purple angles are equal and the green angles are equal. So it's actually easier than the last couple proofs. So we're going to use side angle side here. I think you can see that. Triangle KIT is going to be congruent to triangle KET. And then what we'll do is we can say then that angle IKE is congruent to let's try that again. I have to be a little more careful. Angle IKT is congruent to angle EKT. And then I could also say that angle ITK is congruent to angle ETK. And both of those reasons would come from the corresponding parts of congruent triangles being congruent. These two. And so once I know these two statements to be true, this statement and this statement, I'm going to achieve the goal of having an angle bisector. All right, so let's do this. Gonna just try to make this a little quicker. So I'm going to take my given and stick it here. And then from the fact that I have a kite, I already know that those two are congruent. So I have one congruent statement already. So I need to write my other congruent statement, which is IT is congruent to ET. And so a kite has two pairs of adjacent congruent sides. And we've talked a lot about them being distinct. In other words, KE is never going to be the same as ET, otherwise it will be a rhombus. That's just a little review. So now I have two things that I need. So I'm going to now put in same segment, KT, congruent to itself. Same segment property. And so, therefore, once I have that, I can take this and say I have congruent triangles by side, side, side. And so, since I have congruent triangles, I know I have this, and I have this, because we talked about congruent triangles give me corresponding parts that are congruent. So corresponding parts of congruent triangles are congruent. That's what that stands for. And so now, because I have this angle up here divided into two congruent parts, and this angle divided into two congruent parts, I can say that I have a bisector. So not going to let me copy that one for some reason. I have to write it out. Let's see. Let me try one more time. No. So KT, the result is KT bisects EKI, and it also bisects angle ETI. And the reason comes from up here. We've shown an angle's been divided into two congruent parts. So we just say if an angle is, and what's dividing the angle? It's really a segment, so we should be a little more specific. If a segment divides an angle equally, then it is a bisector. So KT is a bisector. And that's that one. Let's see. That's a shorter proof. I think it's a little bit easier.